Okay, let's dive into something we've all seen, right? The explosion in online shopping and that constant swarm of delivery vans on our streets. But what if there was a way to solve the biggest, most expensive part of that whole system, what they call the last mile, by just completely rethinking how it's done? Well, today, we're going to look at a concept that does exactly that, and it involves this friendly little robot named Pacci.
So here's the crazy thing you have to understand first. Getting a package from a local warehouse to your actual front door is by far the most expensive part of its entire trip. A human-driven van costs about $1.60 per mile. But with automation, like the kind we're about to see, that cost could plummet to just 6 cents. I mean, that's a reduction of over 95%. That is an absolute game changer for this entire industry.
And, it's not just about the money, it's become a total nightmare for our cities. That last little bit of the delivery accounts for over half of all shipping costs, a quarter of a city's emissions, and a fifth of the traffic that's just clogging up our streets. And with deliveries expected to basically triple by 2030, this whole problem is speeding towards a breaking point.
Clearly, we need a smarter, cleaner way to do this. So, some clever engineers asked a really brilliant question. Instead of adding even more delivery vans to the road, what if a robot could just hitch a ride? Piggyback on a system that's already crisscrossing the city all day, every day. And this is their answer. Everybody, meet Pacci. Now, it's an autonomous delivery robot, sure, but it's not like the ones you might have seen. This one was specifically designed to look friendly, non-threatening, to just blend into the sidewalk, almost like it's just another person going about their day.
And here is the big idea that makes Pacci so different. It doesn't drive all the way from some warehouse out in the suburbs. Instead, it uses the city's existing bus network for the long-haul parts of the trip. See, a special carrier on the back of the bus can transport a whole bunch of these robots to their specific neighborhoods. It's basically a logistics system built right on top of public transit. So clever!
Okay, let's walk through how a delivery actually works. It starts just like you'd expect. You place an order on an app. Back at the warehouse, your package is sorted and loaded into a Pacci bot, based on where you live. Then, these fully loaded bots get brought to a bus stop, they're put on that special carrier, and they're ready to start their commute across the city.
So, once the bus gets to the right neighborhood, Pacci just automatically unloads itself. It shoots your notification on your phone, it navigates the last few blocks all by itself, and then it meets you right at your door. And when it's done with its delivery run, it just heads to the nearest bus stop to catch a ride back to the main hub.
It's a really elegant system, right? But making that actually work in the real world is a huge engineering challenge. A city isn't some clean, sterile lab. It's a chaotic mess of bumps and crowds and curbs. So how on earth did the designers make sure Pacci could actually handle all of that?
So first things first, the ride itself. I mean, think about it. Cobblestones, cracked pavement, potholes. How do you make sure the robot stays stable? And, it doesn't scramble the carton of eggs that you just ordered. Well, the solution is actually a pretty sophisticated suspension system. Each one of Pacci's 4 wheels has its very own McPherson-style suspension. That's a design you'll usually find in cars, and it's really good at absorbing shocks. This is absolutely crucial for keeping the ride smooth and protecting both the robot and whatever it's carrying.
Okay, next challenge, maneuverability. A little delivery bot like this has to be nimble. It's got to get around sharp corners on narrow sidewalks, and it needs to weave around people without being annoying. Standard 2-wheel steering just isn't going to cut it.
And here is the beautiful solution: 4-wheel steering. A typical system with 2 steering wheels needs a ton of room to make a turn. But by letting all 4 wheels steer on their own, Pacci can pivot with incredible agility. It can almost turn in place.
And let's put some real numbers on that. With a normal 2-wheel system, the tightest turn it could make would have a radius of about 1 meter. With 4-wheel steering, that drops to just 0.6 meters. That's a 40% reduction, which is a massive, massive advantage when you're trying to get around a crowded public space.
All right, what about one of oldest and most common obstacles for any small-wheeled robot? The curb. I mean, a standard sidewalk curb could easily become an impossible wall and just trap the robot completely.
Pacci was engineered specifically to beat this problem. Its design gives it the power and the ground clearance to climb up vertical obstacles as high as 70 millimeters. That's nearly 3 inches. It's more than enough to handle almost any curb or platform it's going to run into out in the wild.
So where does all that climbing power come from? Well, the motor isn't a separate part. It's built directly inside the wheel hub. Each wheel has its own little compact, brushless electric motor. This in-wheel design is super efficient, super reliable, and it gives the robot independent power and torque control for every single wheel.
So, okay, we've got a tough, agile little robot. But all this cool hardware, it needs power. And that brings us to maybe the most practical question of all. How far can this thing actually go before the battery dies?
To answer that, the engineers didn't just guess. They built a super realistic simulation. They mapped out a whole 7-kilometer delivery route through a real district in Turin, Italy. And they included everything Pacci would actually face: traffic lights, delivery stops, crowds, ramps, even bumpy cobblestones.
And the results from that simulation are pretty impressive. On just one charge, Pacci has a driving range of about 30 kilometers. In the real world, that's enough to complete 4 separate delivery missions in different parts of the city, delivering around 24 parcels in total before it needs to go back for a 5 or 6 hour charge.
So where does all that battery power go? Well, the biggest chunk, about 65%, is just for propulsion, moving the robot around. A pretty big slice, 25%, is used up by all the onboard computers and sensors. But here's the really smart part. About 10% of the energy it uses is actually recaptured through regenerative braking every time it slows down, which helps stretch its range just a little bit further.
So let's just put it all together. You've got a top speed of 30 kilometers an hour, a 30-kilometer range. It can deliver about 24 parcels per charge. It has an incredibly tight 0.6-meter turning radius and can climb 70-millimeter curbs. And it's all powered by those 4 independent in-wheel electric motors. I mean, that is a seriously capable little machine.
But as the lead engineer on this project points out in her thesis, technical specs are only half the story. And this quote really gets to the heart of it all. Success isn't just about how efficient the robot is. It's about whether we, the public, are okay with these things sharing our sidewalks.
And when you see Pacci here just kind of waiting patiently in a public square, you realize it was designed to be more than just a machine. It's meant to be a part of the city, to coexist with us. A robot can be perfectly engineered, but if people think it's annoying or scary or just in the way, it's never going to be adopted.
Which brings us to the final and maybe most important question. The technology is moving at an unbelievable speed. Robots like Pacci are proving that the engineering challenges of last-mile delivery, they're being solved. The tech might be ready for the real world. The real question is, are we?